Hello everyone, welcome. This is a new lecture in your course Shell Scripting using Bash from Radionics. My name is Ahmed. In this section we are going to discuss Bash Input-Output or simply Bash I/O. In previous sections we have discussed several command line redirections. We have seen how we can use the greater than and small than symbols and the pipe symbol in order to redirect from standard input and standard output to a file, or from a file, or using the pipe sign to redirect the standard output of a command to the standard input of another command. However, Bash has a number of other redirect symbols that can be useful in some situations. They can be summarized in the following table. We have already had a look at the pipe symbol here. You can redirect the standard output of this command to be the standard input of the following command, and we have seen examples for this. For example, ps-ef pipe grep followed by the string of text that you want to search in the running processes, for example. But you can also redirect other sorts of output to a file and not just the standard output. If we are talking here about the greater than symbol or the smaller than symbol in this example, you can redirect the standard output by default to a file, but the standard output is not the only thing that a process can output. This brings us to the talk about something called file descriptors. A file descriptor is simply a stream of data that is coming to or from a process. The default file descriptors that are most commonly used with any process is the standard input, which is referenced by the number 0, the standard output, which is referenced by the number 1, and the standard error, which is referenced by 2. However, these are not all the file descriptors that are available to processes. Any process can use as many file descriptors as it needs. If you want to have a look at the file descriptors that are available to any process, you can do this by going to the special file system called /proc. /proc has all the available processes running on the system. It is a virtual file system. These are not regular files. These are not files that contain text or even data. These are just virtual files that represent the properties of different processes running on the system. If you want to have a look at, for example, the HTTPD service, which is for Apache, if we have a look at the process ID of Apache, as you can see here, Apache has several processes. Let's take just one of them. One process ID, which is 11445, and inside the proc file system, we are going to paste this process ID or PID, and it is represented by a directory. This directory contains some of its properties, among which are the fd directory for file descriptors. If you ls through this directory, again, let's type pwd to see where we are. We are in /proc/11445, which is the process ID of Apache, or one of the processes of Apache, /fd, which is the directory containing the file descriptors of this process. As you can see here, these are the file descriptors. This column that is just before the arrow sign is the file descriptor. As you can see here, HTTPD is taking nothing for its standard input. It's taking from /dev/null, which means that it does not accept any input at its standard input. Its standard output is also redirected to dev/null, which means that it does not have standard output by default. However, the standard error will be redirected to the error log of Apache, the well-known error log, which is /var/log/httpd/error_log. This is the standard log file for Apache error. And if you have a look here, we have also two other file descriptors that are not within the commonly used ones: standard input, standard output, and standard error. They're just number 7 and number 8. These are just streams of data used by the Apache web server. For example, file descriptor number 7 is being redirected to /var/log/httpd/access_log. This log represents the clients that access the web server and the requests that they are making to Apache. The developers of Apache have chosen to make a separate data stream for this type of data and assign it to file descriptor number 7, and it is redirected by default to this file. And we also have file descriptor, which is having number 8, that is redirected to /dev/urandom. This might be something related to how Apache is being programmed. What we do care about here is that to know that a process may have more than one file descriptor, and it can have more than just standard input, standard output, and standard error. So in here, if I know the file descriptor of the process, I can redirect this file descriptor, as we have seen in the shell, to a file. So for example, if I have a process that is called, or a command that is called httpd, assuming that we have a command that is called httpd, and I want to redirect the file descriptor number 7, which by default is being written to /var/log/httpd/access_log, I can redirect this to another file like this, another access log. Okay, assuming that I have a command here called httpd that will open a process. I'm just giving an example. This is not how httpd is launched. I'm just giving here an example of a process that is called httpd that will be started by this command. And this is how I can redirect the file descriptor that is called 7 to a specific file. And also the redirect symbol that takes the contents of a file can be redirected to a file descriptor, as you can see here in the example. So here Apache is not having any file redirection. So assuming that I have a process called my process, and this process is accepting data stream number 5, or at file descriptor number 5 from, for example, /etc/password, maybe it is having this file read and the contents of this file to be redirected to data stream number 5 at my process. This is how I can redirect the contents of the file to a file descriptor. I also have the double greater than sign, and this means that the file that will be written to will not be overwritten, which means that by default, if I did something like this, echo hello to my file .text, what's going to happen is that this file, my file .text, will contain the word hello, because echo has redirected its standard output to a file. Okay, now what if I try to echo hello again, for example, to my file.txt? What's going to be inside this file is hello again, and not hello then hello again. But if I want it to be 2 lines, in other words, if I want to append to the file, I can use the double greater than symbol, and now I can type hello to my file and hello again to my file the text, and if I cat my file the text, you will find that all the lines that I have redirected to the file are underneath each other. The double greater than sign has appended text to the file instead of overriding it. Next, we do have something called the here docs. We're going to discuss it in a moment. It is created by using the double less than sign followed by something called the limit string. We'll leave that to its detailed discussion. We do have other redirection symbols, like for example the greater sign followed by a pipe. And this is useful if you have set the no clubber option. If you remember from a previous section when we discussed the shell options, and we said that set -o no clubber means that if you are redirecting to a file that already exists, the shell will prevent you from doing this. So if I set here set -o no clubber, and I try it again to echo hello again to a file using the redirect symbol like this, you will see this message. We have seen that before in a previous example. Cannot overwrite existing file. If you want to override this behavior, you can just add a pipe after the greater than sign, and the file will be overwritten, although I have set no clubber to be true. Another symbol is used with files, which is greater than and smaller than adjacent to each other, and this is mainly used with device files. You may not work with this symbol lots of times because it's specifically for system programmers and those of you who will work with device files. Then we had the greater than followed by the ampersand, and this will duplicate the file descriptor, and this may be used lots of times when you want to redirect both the standard error and the standard output to the same location. Let's say, for example, we have this command ls, and you're giving it gibberish, which will of course result in an error message, and you decided that you want the output of this command to be saved in a file called error.txt, whether it was an error or anything else. If you type enter, you will see that an error message has been typed to the screen, and the error.txt has contained nothing because you have just redirected the standard output to error.txt. If you want to redirect both the standard error and the standard output, you will see that error.txt is empty because you have redirected the standard output only to error.txt. But if you want to redirect both the standard output and the standard error to error.txt, you will have to use something like this, ls, and you give it that false file name, redirect the standard output to error the text and redirect the standard error to whatever you have for standard output, like this. This greater than sign followed by the ampersand followed by the descriptor means that the standard error will be redirected to whatever location the standard output has been redirected to. If I cat error the text, you will see that the message that has been displayed before is now saved in this file. The same behavior can occur if you are using the smaller than sign, which is used, as mentioned before, to grab the output of a file. And one shorthand of redirecting both the standard output and the standard error to a file is using ampersand followed by just a greater than sign. So we can do, let's remove error the text, and let's do that again, but this time using just an ampersand and the file, and it will have just the same effect. So this is just a shorthand for duplicating the file descriptor output. And finally, we have the and followed by the smaller than sign, and followed by and, or ampersand minus, and n followed by greater than sign followed by ampersand minus, and these are specifically for programmers. They are used to close the standard input or the standard output. So most of those redirection symbols will not be used in your daily shell scripting life, but maybe if you will be working with shell programming or some low-level programming, you will need some of those. Now let's have a look at the here documents or the here docs. By default, here docs are used to save multiple lines of text programmatically to a variable or to a file in a shell script. The most prominent example is the mail message. The mail message has a specific format that has to be followed if it is going to be used in a mail system. It has to start with the word from followed by a colon, followed by the sender email address, then the to, followed by a colon, followed by the recipient email address, and then an empty line. There must be an empty new line before the body itself. Then the body, of course, of the message, which may contain multiple lines. So in our example, if you want to have this in a shell script, if you want to save those multiple lines in a shell script, it might be done like this: vim message.sh, and this file is going to be used to save an email message or to construct an email message. Let's first define our variables. To root at shell bash scripting, for example, .dev, from client at bash script.dev. Okay, message file itself is message.txt, then echo from, then new line, echo to, then new line, then an empty line like this using the echo command, then echo the message itself, like for example, dear admin, this is my first line. Okay, it would be something like this. You are defining three variables at the top of the script, then you are echoing different lines to be entered in the message file using the double redirect symbol here in order to append to the file. Okay, then you save. Okay, then you execute, and now you have message.txt that has a nicely formatted email message. Okay, but there is a much easier way to do what we did here. Let's comment out those lines. It's called the here docs. All what we have to do is type the cat command followed by the double redirect symbol, which is the symbol used for the here docs, followed by something called the limit string. The limit string is just a character or a group of characters that are used to be the delimiter of, or the end character or the end statement of the lines. In other words, whenever here docs sees this EOT at your text on a separate line, this means that you are ending your input. Let's redirect all the output to message file like this. And once we are inside the here docs block, we can start entering text as if we are echoing it. However, we don't need the command echo. Just format your message as if you are typing it in a word processor program like Notepad, for example. I'm leaving the empty line and I'm typing the very same message. Okay, and once I'm finished, I will have to put my EOT, which is the limit string. And once cat sees this group of characters at your lines, this means that the input that will be further put in message file is finished. Let's just change the file name to be message_hd for here docs. Let's save and let's run the script again. Okay, and if we have a look at message underscore here docs or ht.text, you will see that it has exactly the same sort of output, but the difference is that it's much nicer, and it may be more useful if you are trying, for example, to write HTML documents. If you have coded HTML documents before or XML documents before, you know, those documents that have syntaxes like this, HTML. Now imagine that you are using the echo command in order to write all these lines, and of course a normal HTML document will contain at least 10 to 15 lines to name the list. So using the echo command in order to echo each and every line that will be added to a file, an HTML file or any long file, is just a waste of time and effort. The HereDocs are here for the rescue. You can use it to enter multiple lines containing any sort of formatting you wish, as if it has been entered using the echo command. And let's continue in the next lecture.